Things you should already know. You should already know how to write an angle as a fraction of a circle by putting that measured angle over 360 degrees. You should already know how to calculate the circumference of a circle using the formula pi d or 2 pi r. So we're dealing with circles, and there are some key terms that we must know. If we don't know them, we'll have to look at them and know them, all right? So the first one is a fraction. And from primary school, we know that fractions are a part of a whole. For example, a half. Second one is the circumference. And that's a perimeter of the circle, so to speak. It's the total distance around the edge of the circle. Then pi. Pi is the number of times that the diameter can go around the circle. And its value as a fraction is 22/7, and as a decimal it's 3.142. The arc. The arc is just a fraction of the circumference. It's really just a part of it. So it's a little curve. So the small curve is called the minor arc, and the large curve is called the major arc. The sector. The sector is a fraction also of the area of the circle, with its angle pointing at the center of the circle. It's shaped like a pizza or an ice cream cone. So we're still on circles. Now, if I'm dealing with perimeter or circumference in the case of a circle, and I'm just interested in a fraction of the circumference, the fraction of the circumference would be this part, right? This little part right here in blue. It's just a little piece of the circumference we want, not the entire thing. No, we said that the fraction of this circle that we're interested in is theta over 360, and theta is really just the angle. So the angle is 52 degrees out of 360 degrees. Now, if it is that I want to find out how much this arc measures, and remember the arc is just a piece of the circumference. So if we want to find out how much that arc measures, I have to multiply this fraction. Let me write it out for us again. I have to multiply theta over 360 by the circumference. And remember that we calculate the circumference using the formula pi d. So if I really want to find out how much does this blue arc measures, I have to multiply theta over 360, which is a fraction of the circle, by the circumference of the entire circle. Now, if we didn't have the diameter, as in this case, we only had the radius, which is from the center of the circle to touch one point of the circumference. And remember, center of the circle, 1 point of the circumference. So this also measures 3 centimeters. Now, we didn't have the diameter, but we know the relationship between the diameter and the radius. We said that the diameter is 2 times the radius. So to calculate the length of this arc, we have theta over 360 degrees multiplied by pi times 2r. To see this easier, we can see pi over 360 degrees, theta over 360 degrees multiplied by 2 pi r. All we have to do from here is to just substitute the values for theta, pi, and r. Based on our diagram, we know that theta is 52 degrees. So wherever I see theta, I'm going to replace it with 52 degrees. I'm following my formula. Multiply comes next. Times by 2. Times by pi. And we know that pi is 22/7. And I'm going to multiply it by the radius. What's our radius? It's 3 centimeters. And remember, it's a circle. So all the radius measures the same length. 3 centimeters. Now, to get the length of this arc, all I have to do is to put it in my calculator and let the calculator help me. So my calculator is right here. So I can multiply everything that's at the top. So I'm going to say 52, there we go, times 2 times 22 times 3. I'm going to get 6,864. So this will all give me 6,864 centimeters. Now I'm going to divide that by the multiple of everything that's on the denominator. So that is 360 times 7. So 360 times 7 will give us 2,520. Now to find the length of this arc, so I'm going to divide 6,864 by 2,520. 6,864 divided by 2,520, and I end up getting 7.238. So when I look at it, that is what the length of the arc will be. The length of this arc. Here it is. So this blue part from this end to this end will be 2.72 centimeters. So recap. To find the length of this arc, we have to find the fraction of the circle that it represents and multiply it by the circumference of the circle, right? So the fraction of the circle is theta over 360 multiplied by pi d, which is the diameter, or you could choose this formula, theta divided by 360 multiplied by pi 2r or 2 pi r. Any one of them works as long as you're multiplying the fraction of the circle by the circumference of the circle. Doesn't matter. Same exact thing you're going to get back. And that's how you calculate the length of the arc. So a trick question that we usually get is to find the perimeter. Let me write it for you. Find the perimeter of the sector. And this pizza looking shape is really a sector. It's a fraction of the circle. So what you have to do is, remember, perimeter means adding up all the sides. So this side plus this side plus this side. So we know that this side is 3 and this side is 3. And from our calculations, we found that the length of this arc was actually 2.72 centimeters. So to find the perimeter of this sector, I have to add up all the sides. So I'm going to have, let me label it, A, B, and C. So the perimeter would be side AB, P for perimeter, plus, so AB plus AC plus CB. So you have to add up all the sides. So AB measures 3 centimeters. AC, it measures 2.72 centimeters. 2.72 centimeters plus CB is 3 centimeters. 3 centimeters. So when I put this all together, 3 centimeters plus 3 centimeters will give me 6 centimeters, and I'm adding 2.72 centimeters to it, right? So I'm going to get 8.72 centimeters, and that's the perimeter of this sector.